Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Today we are going to do physics, part 6, that is from chapter 13, magnetic effects of current.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
So the first question says, PQ is a current carrying conductor in the plane of paper as shown in the figure below. Let us understand the meaning or the language of the question. That means this says that we have a plain paper like this. Suppose this is a plain paper, and on the plain paper, we are keeping a conductor, that is PQ. Again, I repeat, we have taken a piece of paper, plain paper, and then we have kept a conductor on it that is named P and Q. But which kind of conductor? That is a current carrying conductor. Always keep it in mind. And current is flowing from where? From Q to P, C, in this direction. So this is really very important to note that what is the demand in the question. And the 2 points are there with conductor, that is R and S. Where you have to find what? Where you have to find the direction of the magnetic field produced. At which points? That is R and S. So this is the first part of the question they are demanding for. Okay. Now the second part says, given R1 is greater than R2, where will the strength of the magnetic field be larger? Give reasons. Okay. So here they are showing that is R1, R2, and you have to find the strength of the magnetic field over here and over here, but where it will be larger. On which point it will be larger, that we have to find out. That means we have to give the reasons to children. Now children, over here, little bit more understanding we have to create. That is R1 over here. Are you seeing over here R1? Yes. So R1 is distance of point R from current carrying conductor, that is PQ. This is the name of the current carrying conductor given, PQ. Okay. And R2 is the distance, that is what? Of point S from current carrying conductor PQ. So we have understood the meaning of R1 and R2, and they have also given in the question also that R1 is greater than R2. This we are knowing from the question only. So one more thing we are seeing and viewing and observing over here, that point R is away. See children, that point R is away from current carrying conductor Q. In comparison to what? In comparison to the point S. That means this point S is closer to the conductor. Which conductor? Current carrying conductor PQ. So these things we have observed in the diagram, whether given in the question or not. So these minute concepts you have to keep trying in the question and keep it in your mind. Whatever concept you are aware of, keep it in mind, collaborate, and then take out the answer. Okay, the third part says, if the polarity of the battery connected to the wire is reversed, quote the word reverse, children. How would the direction of the magnetic field be changed? That means they are saying that if polarity changes, what will happen to the direction of the magnetic field? Will it change? What is the reason? If it does not change, what is the reason? So in both the ways, you have to give the reasons no matter whatever you say. Okay, the meaning of reverse you have to understand, children. Over here, suppose this is a battery over here, you're seeing it. And over here on the terminals, you see over here negative and positive. After this, you say the question demands that the polarity of the battery connected to the wire is reversed. Try to understand the meaning of reversed. Reversed does not mean that this positive will come here and negative will come here. No, no way. Do not understand like this. But the correct way to understand is that reversed word is used, children, over here. So that means you will pick up the battery and you will reverse like this. Rather changing these charges, you will reverse the battery. So this positive will come here when you reverse and the battery will be placed like this. So this part will be having now positive and this part will be having now negative. So always understand the meaning of the word reversed, that you have reversed the polarity of the battery connected to a wire by reversing it. So this we have done it. So this is very, very important, children, to note down what is given in the question and what do you understand. You just see the concepts which you are knowing according to the parts of the question. Now in this question, children, you are also saying that so many concepts are collaborated in one question only. So that means you need to know the concepts and it is not compulsory. The whole of the question can come like this. They can pick and choose even the part of this question. They can choose only two parts of the question, or if they feel, they can give you the whole part as it is the question. That means I'm trying to tell you that so many concepts are there in one question only, children. So please study it very, very carefully when you are revising the chapter very well. Okay, after this, children, you should also know one thing. What? You know it when you were studying the chapter that B is directly proportional to what, children? Current. And what is B? Magnetic field. We are aware about it. We are aware about it, that how it is designated, so we know it very well. Okay. Now, if B is directly proportional to I, that is, magnetic field is directly proportional to I, that is, it is full-fledged dependent on current. Okay. If conductor is becoming electromagnet, please try to understand, children. Very, very important. If conductor is becoming electromagnet, that is having what? Magnetic field. Very, very true. But how? Because it is a current carrying conductor. That is, current is flowing. And then conductor has magnetic field. Absolutely correct. That is, current is producing magnetic field. Very simple. If conductor is having good flow of current, I repeat, if conductor is having good flow of current, magnetic field will be very strong. And if it is not having good, that is flow of current, not having good flow of current, so what will having? So what will happen, children? Magnetic field will not be strong. And direction also changes of magnetic field according to the flow of the current. These concepts you are aware of. Collaborate and start giving the answer. So this you have to understand, children, how to go for the concepts, collaborate, put it in words on the demand of the question. Okay, one more thing. This I've told you and elaborated also about the concepts connected with it. We also know, children, that strength of magnetic field is inversely proportional to what? Distance of point from conductor. This is what you are seeing, children, over here in the diagram which are given. Okay. Now, we should also know that if distance is more, of what? Of over here you are seeing on the diagram. If distance is more, what will happen? Magnetic field will be less. Of course, when the distance is more, that means this point R is away from the conductor PQ. Of course, children. So, magnetic field will be less. If distance is less, that is distance from where? Distance of this point S from the conductor, that is the current carrying conductor, is less, that is the distance is less. What will happen? Magnetic field will be more. Obvious. Very, very important and very simple and true. That I have understood. So, all these concepts, when you have understood point wise, the part wise in the whole question, then after collaborating all the concepts, we can give the answer. Now we are very confident in giving the answer of all the 4 parts of the question. So we are ready. That means we are knowing about the concepts about every part, and now we are going to answer them. Okay. Now, children, the first part which I told you, find the directions of the magnetic field produced by it at point R and S. That means you will say, according to right hand thumb rule, the magnetic field produced by PQ at point R is into the plane of the paper, which I told you in the beginning. That we are having a plane of paper and we have kept the conductor, that is the current carrying conductor, PQ, over it. And at point S is out of the plane of paper. Now you're seeing it, children. See over here. If you are seeing this diagram, the diagram which was given, of course, we know it, that it is also connected with the battery. Of course, we know it very well. And children, if we show our hand, that means which hand? You know it, right hand. If we show it, what will happen, children? That the thumb will be up and my all these fingers, which I'm showing it over here, will curl inside the paper. Are you aware about it? Which I told you in the beginning, that the curls of my fingers are going inside the paper. That is towards the paper. Are you getting? So this is the paper, this is the conductor kept, and then my hands of this, this curling of my fingers are going towards the paper inside. And when I keep on, curling my fingers, I will keep on curling like this. My thumb will go over here and my curling of the fingers will come outside the paper. So I will start with the curling inside the paper. Then again, I will keep on rolling it, curling it, my fingers, and it will come outside the paper. Clear, children? Now, the second part says, given R1 is greater than R2, where will the strength of the magnetic field be larger? Give reasons. Okay. Over here, I told you that we know it, that this R1 is greater than R2. So my answer is done. What it is? The magnetic field will be larger at point S over here, which I told you in the beginning, as compared to that at point R. This is because the magnetic field produced by a straight current carrying conductor is inversely proportional to the distance from the wire. So, the magnetic field will be larger at point which is nearer to the conductor. Of course, as point S is nearer to the conductor as compared to point R. So, field at S is greater than field at R. Done. If we are knowing the concept, we can put it in words very easily, children. Okay, third part. If the polarity of the battery is reversed, the current will be going from top to bottom in the wire. Over here, top to bottom in the wire. That means now the current was going previously, that is what? From Q to P. Now, if the polarity of the battery is reversed, what will happen? That means the current will come from top to bottom. When the curling of the fingers were done over here, it was curling towards plane. So, it was anti-clockwise, children. When the curling of the fingers were going inside the paper, it was anti-clockwise and the current was going from Q to P. When the polarity of the battery was reversed, what happened? My curling of the fingers came out of the plane and the current started flowing from P to Q, that is top to bottom. So it was showing clockwise. This is what it is written over here, children. If the polarity of the battery is reversed, the current will be going from top to bottom in the wire and the magnetic field lines will now be in a clockwise direction on the plane, which is perpendicular to the wire carrying current. So always, start connecting the concepts with each other. And of course, when you connect the concepts, children, of course, the answers are in your hand. And you can grab the marks in your exam, but that too full and fledged. Okay, last part. Explain the rule that is used to find the direction of the magnetic field for a straight current carrying conductor. Okay, we know this very well. It's very simple. Maxwell right-hand thumb rule is used to find the direction of the magnetic field for a straight current carrying conductor. This law states that if you hold the current carrying straight wire in the grip of your right hand in such a way that the stretched thumb points in the direction of current, then the direction of the curl of the fingers will give the direction of the magnetic field. Whatever we were doing it, we have put up in words for this last part of the question, and the answer is done with my concepts which I was aware about it previously only. Only the thing is, I have put up my concepts according to the demand in the question, collaborated, connected, and the answers are ready for me for the exams. Am I clear, children? So, are you seeing, children? This is a pretty long question, very long question, and so many concepts are pouring into it. Yes or no? So, when so many concepts are pouring into it, so this is the best question, these type of questions, where all the concepts come out at one place and the answer is ready for such a big question. So keep on revising, children. Your exams are very close by. So keep on revising. Day and night study, children. But take care of yourself also. Take sound sleep and eat well. With this, I wind up the session. Bye-bye. God bless.